Hi mathematicians, this is Mr. Almeida. I hope you're doing well today. This video is going to explain how to go about solving percent problems. So before we do that, I just want to review with you what a percent is. So a percent is a complex fraction whose denominator is 100, okay? So remember, a complex fraction is the division of two fractions. So it's the fraction we get when we divide two numbers. So it's a complex fraction whose denominator is 100. Instead of writing a denominator of 100, you can replace it with a percent sign. So say you want to write 30 hundredths. We could replace the 30 hundredths with the numerator, which is 30, and the denominator with the percent sign. And as you can see, the little fraction bar is in the percent symbol, and the two zeros that are in the denominator are in the percent symbol as well. So when you see a percent, you write it as a complex fraction whose denominator is 100. Okay, so for example, if you have 45%, you're going to rewrite that as 45 as the numerator all over 100. And that's the denominator. What if you had 3.5%? You would write that as 3.5 all over 100. Now remember, 3.5 is really 35 tenths, and that's being divided by 100, okay? So I just wanted to let you know what percents are. The basic structure that you're going to want to use when you're dealing with percents is this structure right here. So what is a percent of a number? So we're going to have percent times a number. That's going to be your unit. Whatever you're finding a percent of, that's what your whole is. And this is going to be your part right here. So if you're asked what is 30% of 20, you're going to translate it and write an equation. What is the number we're trying to find? We don't know what it is yet, so we're going to represent it with x. So x equals 30% times of is times, and then 20 is 20. Now we are looking at this equation, and we notice that the goal of the equation is to get the variable or the letter x by itself. X is already by itself, so I don't need to do anything to the left side of the equation. All I have to do is simplify the right side of the equation. So I write 30%, which is 31 hundredths. So I have x equals 31 hundredths times 20. Now what am I doing here? I'm multiplying fractions, so I'm going to use the product formula. 30 times 20 all over 100. So x equals 30 times 20 all over 100. And when I look at this, I know I can simplify. I can divide both the numerator of 30 and denominator of 100 by 10. I get 3 tenths. And then I can divide the 20 and 10 by 10, and I get 2 all over 1. So 20 divided by 10 is 2, and 10 divided by 10 is 1. Now I have x equals 3 times 2, which is 6, divided by 1, which is 6. X equals 6, okay? So that's how you would solve equations when it comes to the percents. This is the general structure that you're going to set up your problems with, okay? So it's always going to be percent times a number equals the part. So percent times the whole, or the total thing that you're talking about, equals the part that you're trying to find, okay? So let's apply this to this problem right here. It says, what is 80% of 60? So there really isn't a word problem here. It's more like just translating. So we have x. Let x be the number that we're trying to find. That's x. Let x be number. And we have x is, so x is equal to 80% times of 60. So remember, we're looking in an equation to get the variable by itself. The x by itself. Is the x already by itself? Yes. So that's great. We don't have to do any work on that side. Now we just have to do the translating here. 80% is 80 hundredths times 60. So now I'm just going to write this as a multiplication dot, so we see it as multiplication. I'm not thinking it's the x. Now we're going to use the product formula over here, and I'm going to simplify. So I get 80 times 60 all over 100. I'm using the product formula on this side. Now I'm going to try to simplify this Is there a number that can divide the numerator and denominator? 80 and 100? Yes, 10. So I get 8 here, and 100 divided by 10 is 10. Is there a number that can divide? I could keep on going with 8 and 10, but I'm going to do 60 and 10 because in my mind, they both end in 0, so that's easy to think about 10. So 60 divided by 10 is 6, and 10 divided by 10 is 1. Once we have 1 in the denominator, we know we're kind of done with the denominator. We don't have to worry about it. So we get 8 times 6 is 48, and 48 divided by 1 is 48. So we get 48, and we put that into the equation over here. X equals 48, okay? All right, next we go to the word problem, all right? And remember the general structure that we're thinking about? We're thinking of some percent times some number, the whole, equals some part, okay? So we have Matthew's Cafe offers 2 kinds of espresso, single shot and double shot, okay? So we have single shot and double shot. I'm going to write all the information underneath. Oh, and then I have the total espressos. So I have espressos that are single shot, espressos that are double shot, and then I have the total number of espressos. Okay, and then I'm going to put the information underneath each of these labels so I can use it later. So it says, yesterday afternoon, the cafe sold 40 single shots. So I'm going to put that here. That's the number of single shot espressos. And those single shot espressos was 20% of the total of all the espressos sold. So 20% goes with the single shot. And I don't know how many double shots so far. And the question is, how many espressos did the cafe sell yesterday? So I'm going to write a T for total. Let T be total. Total shots. Okay? The total espressos. So I have to write an equation that's in the form of some percent times the total equals some part. Okay? So I have 20% of what total of times the total, T, equals 40. So this expression right here, 20% of the total, will give me what an expression for how many single shot espressos there were, and 40 also gives me the number of single shot espressos. So therefore, both of these expressions are talking about the exact same thing. Therefore, they are equal to each other. So I'm going to rewrite this. So I'm just going to use the commutative property here as I'm writing it. I'm going to write T times 20%, which is 20 all over 100, 20 hundredths, equals 40. So I look at the equation. Remember, the goal is to get T by itself. Is T by itself right now? No. So I'm going to have to divide both sides by 20 hundredths because I'm multiplying by 20 hundredths. So we always do the inverse of what we're doing. The inverse of multiplying by 20 hundredths is to divide by 20 hundredths. So I'll do that on both sides. I'll divide both sides by 20 hundredths. When I look at the left side, both the numerator and denominator, they cancel the 20 hundredths. I'm left with T on the left side equals. Now off to the right, I will do my division. 40 divided by 21 hundredths. 21 hundredths. What does it mean to divide by a number? To divide by a number is to multiply by that number's reciprocal. So I'm going to multiply by 120ths. And then I'm going to use the product formula because I'm multiplying fractions. And then I'm going to divide. Is there a number that can divide 40 and 20? Yes, 20. So I'm going to divide 40 by 20. I get 2. And 20 divided by 20 is 1. Therefore, I have 2 times 100, which is 200. And 200 divided by 1 is 200. So I get T equals 200. Okay? And then because this is a word problem, I just want to make sure that I'm putting the unit there. So 200 espressos. T equals 200 espressos, okay? All right, let's move on to the next one. For a company picnic, Marlon ordered a box of fresh-baked gingerbread cookies and sugar cookies. The box included a total of 30 cookies, and 24 of them were gingerbread. What percent of the cookies that Marlon ordered were gingerbread cookies? All right, so let's think. We're talking about cookies here. So I know I'm going to have gingerbread cookies. I'm going to abbreviate for gingerbread, for ginger. Then I have sugar cookies. Then I have total cookies. Now I'm going to use this to organize my information so I can make my expressions, or I can make my equation, okay? The first sentence just gives me the information that there are two types of cookies. The box included a total of 30 cookies, so I know that 30 goes underneath here for cookies. 24 of them were gingerbread, so I put that under gingerbread. And I'm finding what percent of the cookies. So what percent were gingerbread? So I'm looking for the percent. That's the question right there, okay? What percent are cookies? So remember, when we're going to write this equation, it's going to be some percent times the total equals whatever percent goes with that label. So whatever number goes with that label, and in this case, it's 24. So we have n percent, n hundredths, times the total is 30. And now this gives me an expression for the number of gingerbread cookies. Therefore, this is equal to the number of gingerbread cookies, because 24 also gives me an expression for the number of gingerbread cookies. So now I ask myself, is n by itself, because I have an equation? And the answer is no. So I have to get n by itself. To do that, I'm going to use the product formula here and ask myself, what am I doing to n? I'm multiplying it by 30 100ths, because that's 30 all over 100. So the inverse of that is going to be to divide both sides by multiplying by 30 hundredths, which is to divide by 30 hundredths. I'll divide both sides by 30 hundredths. On the left side, I notice that the 30 hundredths, the numerator and denominator, they cancel. I'm left with n equals, and then off to the side, I'm going to do 24 divided by 30 100ths. Remember, what does it mean to divide by a number? To multiply by its reciprocal. So 130ths. Then I'm going to use the product formula. And I'm going to simplify before I multiply. Is there a number that can divide 24 and 30? Yes. But I'm going to pick 130 because I know they both end in 0, and I know 10 divides both of them. So 100 divided by 10 is 10, and 30 divided by 10 is 3. Now, is there a number that can divide 24 and 3? Yes, 3. So I get 8. 24 divided by 3 is 8. And 3 divided by 3 is 1. I'm then left with 80 times 10 all over 1. So 8 times 10 is 80 divided by 1, which is 80. So therefore, n equals 80. However, I wasn't asked to find what n was. I was asked to find n percent. So I'm going to write n percent equals 80% of cookies. And that's what percent were gingerbread, okay? So that's how you solve these percent word problems. You're always going to set up that equation. Some percent times a number equals the part. So some percent times the total equals some part. So always set this up, pull the information out, and then set up your equations accordingly.